with Unit 9. This is the second part of Learning Target 9b. So in the first part of Learning Target 9b, we learned how to solve quadratic equations by graphing and by using square roots. So we talked about these two in our last video. In this video, what we're going to focus on is how to solve quadratic equations by using the zero product property. We do have the added restriction though that this won't work for every single quadratic equation, but it will work for any quadratic equation that we can factor. So as we're learning about the zero product property, we are also going to get a review in factoring. What the zero product property says is for any real numbers a and b, if I have those two numbers multiplied together, or those two terms multiplied together and it equals 0, then that means either a was equal to 0 or b was equal to 0. In our example down here, I'm going to have this x plus 3 is representing our a term, and the x minus 2 is representing that b term from that example, or that definition up above. I don't know why that keeps jumping weird like that. So our x plus 3 is our a term, and our x minus 2 is our b term here. So if I have x plus 3 times the quantity x minus 2, remember this right here is a quadratic equation that is in factored form. So we are already factored here, which is what we'll need to use the zero product property. I have x plus 3 times x minus 2 is equal to 0. Then what the zero product property tells us is that x plus 3 equals 0 or x minus 2 equals 0. So when I have a product of two or more things and they are set equal to 0, then it means that one of those factors has to be equal to 0. What this allows us to do is take a quadratic equation and break it apart into two linear equations which we can solve. So for this first example of x plus 3 equals 0, we can solve this for x by subtracting 3 to the other side and getting x equals 3. And then for our second one of x minus 2 equals 0, we can solve that by adding 2 to the other side and getting x equals 2. Together, these two would be our answers to our quadratic equation, x plus 3 times x minus 2 equals 0. So although the zero product property does say or, where a equals 0 or b equals 0, since we're solving for all of our solutions, we have to make sure we write both of them, since they're both potential places where this equation will be true for x. Let's look at a couple examples. So for all of these examples, it says solve the following quadratic equations by using the zero product property. Remember, step 1 of the zero product property is I want to be equal to 0. So I have to make sure that my equation is equal to 0. That's part of the definition of the zero product property. Step 2 is I have to be in factored form. So for us with quadratic equations, factored form is going to look like something here times something else, and then of course this will be equal to 0. So if we have something that's already comes in factored form and it's set equal to 0, then we can go ahead and do the zero product property right away, like we did in this example up here with the x plus 3 times x minus 2 equals 0. If one of these is not true, then we will first need to rewrite and manipulate that quadratic equation so that then we can apply the zero product property. Our first example says 4x plus 1, that quantity, times x plus 2 equals 0. Well, I know that I'm set equal to 0, so the first thing is checking, but am I in factored form? What do you guys think? Is this quadratic equation in factored form? So yes, we are in factored form since I have two linear factors here, so both of these have an exponent of 1, and I have the 4x plus 1 in parentheses times our x plus 2 in parentheses. So because I'm set equal to 0 and because I'm already in factored form, then I can apply the zero product property right away, and what that tells me is that 4x plus 1 equals 0 and x plus 2 has to equal 0. So I'm breaking this apart right here by applying the zero product property and setting each factor equal to 0. And now we can solve each of these equations on their own. So for the first one, I'm going to subtract 1 over and get 4x equals negative 1. Then the last step would be to divide through by 4. And we get x equals negative 1 over 4. For our second equation, to solve this guy, we're going to want to subtract 2 over, and we get x equals -2. That right there then would be our 2 answers for our first example. Just like we saw in our last video, quadratic equations can have at most 2 answers, but some of them might only have 1 and some might have no real solutions. Let's look at our second example. We have 7x minus 2 times 3x minus 4 equals 0. Why don't you guys pause the video and solve this one on your own first? So for example 2, I'm already set equal to 0, so that step's good. The next thing I have to make sure is that I'm in factored form, and we are indeed in factored form since I have x minus 2 as a factor times 3x minus 4 is my other factor. So I can go ahead and use the zero product property, which tells me to set each factor equal to 0. So we get 7x minus 2 equals 0, and 3x minus 4 equals 0 as well. Now that we've broken this apart into 2 separate equations, we can go ahead and solve each one. To solve the first equation, we can add 2 and then divide by 7. So we'll get x equals 7 over 2 as our first answer. For our second equation, we need to add 4 over and then divide by 3. So our second answer to this will be x equals 4/3. And together, that makes up our final solution. And we would want to have both of those answers to have a correct problem then. Let's look at example 3. So example 3 says -8x times x, the quantity x plus 1 equals 0. So we're set equal to 0. That step's already taken care of for us. Are we in factored form? What do you guys think? Do you think this is in factored form or not in factored form? So this one is actually in factored form as well. Although the first factor here, which is -8x, is not in parentheses, I could have parentheses here if we wanted to put them, but they're actually not necessary since our first factor here is just a single term of -8x, which is why usually you will not see parentheses written around it, but if you would like to add those parentheses to help you see it, you are able to. Our second factor then here is x plus 1. I can use the zero product property by breaking this apart and setting each factor equal to 0. So we get -8x equals 0 and x plus 1 equals 0. From here, to solve for x in the first equation, I can divide through by -8, and I end up with x equals 0 over -8. Well, what does 0 over -8 reduce down to? 0 over -8 reduces down to be 0. Remember, that's that special case where it's okay to have 0 on the top and a non-zero number on the bottom. So this is okay, and that's equal to 0. In our second problem, to get x by itself, I can subtract 1, and I get x equals -1. Together, those 2 answers are our solution, or is our solution. Okay, let's look at example 4. It says x squared plus 8x plus 15 equals 0. So step 1, I'm set equal to 0, so that's good. Are we in factored form? What do you guys think? Is this quadratic equation in factored form? So this quadratic equation is not in factored form. We are actually in standard form here since we have our x squared term plus our x term plus our constant. So our first step here is I actually need to factor this guy first. Why don't you guys pause the video and as a little review, factor x squared plus 8x plus 15. Okay, let's check our factoring. So on the side over here, I'm going to draw up my x games to help me organize my thought process. I'm looking for 2 numbers that multiply to be 15 and add to be 8. The 2 numbers that work are going to be +3 and +5. So what that tells me then is that x squared plus 8x plus 15 is written in factored form as x plus 3 times x plus 5. So the x squared plus 8x plus 15 can be rewritten in factored form as x plus 3 times x plus 5. Because the original problem was equal to 0, the factors are still equal to 0. So in factoring right here, we've just replaced the standard form with the equivalent factored form. And the reason we did that was we need to have our quadratic equation in factored form to be able to use the zero product property. Now that it's in factored form and set equal to 0, I can set each factor equal to 0. So we get x plus 3 equals 0 and x plus 5 equals 0. To solve each one of these, to isolate x, in the first one I'm going to subtract 3, and then in the second one I'm going to subtract 5. So the two answers we end up getting are x equals -3 and x equals -5. So in example 4, we can see here we had to do a little bit more work, and we had to actually factor this problem first before we can use the zero product property. And that will happen sometimes, but we've practiced our factoring in our last unit, and so we're just incorporating that as an additional step. Okay, let's look at example 5. So we have x squared minus 5x minus 14 equals 0. So I'm going to keep our list over here of the two things that need to be true. So we need to be set equal to 0, and the second thing is we need to be in factored form before we can apply the zero product property. So in example 5, we're definitely set equal to 0. Are we in factored form? What do you guys think? So in this example, we are not in factored form. We're back to being in standard form again. And the reason I know that this is not factored form is factor form would have our parentheses, and I'd have something here, so something linear. So let's say x plus 10 maybe, and then times another linear term of maybe x minus 1. So factored form has those two linear terms that are being multiplied. Here, because I have this x squared, I know there's no way that I'm in factored form yet. Why don't you guys pause the video and factor x squared minus 5x minus 14 first on your own. Let's check our factoring. So I'm going to draw my x games to help me organize my work. We are looking for two numbers that multiply to be -14, since that's our C term, and add up to be -5, since that's our B term. The two numbers that work here are going to be -7 and +2. So I can rewrite this x squared minus 5x minus 14 instead as x minus 7 in parentheses times x plus 2. And because the original was equal to 0, this will also be equal to 0. Now that we are in factored form, we can go ahead and apply the zero product property. Why don't you guys finish out the problem and solve for your two values of x, and then we'll check it together. Let's check our answers on example 5. So to apply the zero product property, I can set each term or each factor equal to 0. So I have x minus 7 equals 0 and x plus 2 equals 0. That step is where we applied the zero product property. To solve each one of these, to solve the first guy, I'm going to add 7 and get x equals 7. And on the second guy, I'm going to end up subtracting 2 and getting x equals -2. Some of you might be wondering if it is necessary to show all this work, and it is. So you guys are going to be required to, if you need to factor it, rewrite the quadratic equation in factored form first. So this first line here is necessary. You don't need to draw out the x games, especially I know some of you might be using other methods to factoring. That's fine if you have the scratch work or if you don't. You do need to have the step where you show that you split this quadratic equation using the zero product property, and then of course we want to make sure we have both of our final answers down here. Okay, let's do example 6. Example 6 says x squared plus 14x equals -49. Well, this is definitely not set equal to 0 since I have the -49 on the other side. Any suggestions for how we could make this set equal to 0? So to set this guy equal to 0, we could add 49 to both sides and get x squared plus 14x plus 49 equals 0. Now that we're set equal to 0, that step is taken care of, but are we in factored form? So in this case, we are not in factored form. Why don't you guys pause the video and factor this quadratic equation in example 6. Okay, to factor this, we're looking for two numbers that multiply to be 49 and add to be 14. In this case, 7 and 7 are going to work. So we get x plus 7 times x plus 7 is equal to 0. Oops, that was a 0. Now from here, there's actually a couple ways that you guys could solve this. So the first way we could solve is to apply the zero product property. So I'd get x plus 7 equals 0 and x plus 7 equals 0. So I don't really need to write that twice since the factors are the same. And I would end up getting x equals -7. An alternative way to write this was if you guys had instead rewritten this as x plus 7 squared, that's okay, that's equivalent. And what we would do from here is actually something we learned about in our last video. So in this method, what we would want to do is apply the square root here so that, let's make sure that exponent is inside our square root. So the reason we're applying the square root is we learned in the last video that if to cancel a square, if I square root both sides, they'll cancel each other out and I'd get left with x plus 7. On the right side, we technically get plus or minus the square root of 0, but the square root of 0 is just 0 and there is no difference between positive or negative 0. And then to get x by itself, I'd do the same thing that we did using the other method and we'd solve and get x equals -7. So using these two methods here, we can kind of see how stuff from one method can kind of overlap into another method here. And one way to solve this would be to factor it and then actually use square root since the factors were identical, or you could apply the zero product property to this as well. So there's definitely more than one way to solve all of these quadratic equations, and this second part of this unit is all about learning different methods. And we'll talk about how sometimes there's methods that make more sense than others, depending on what the problem has in it. Okay, let's look at example 7. So example 7 says 5x squared minus 2x equals 0. We are set equal to 0, so that step is taken care of. Are we in factored form? What do you guys think? So in example 7, we're actually not in factored form, so we have to go ahead and factor this first. Why don't you guys pause the video and factor 5x squared minus 2x. Hey, to factor 5x squared minus 2x, if you started doing an x games, you need two numbers that multiply to be 0 and add to be -2. You also have a leading coefficient here that might cause some trouble. So instead, the first type of factoring we should always think about is, do I have a greatest common factor? So what do you guys think? Is there a greatest common factor between 5x squared and -2x? So there is a greatest common factor here. It's not very exciting. It's actually just x. And because there's a greatest common factor, before I try any other type of factoring, I want to go ahead and factor that GCF out. So by taking out the x in front, we're left with a 5x minus 2 on the inside. And of course, this is still equal to 0. This is actually factored form now because I don't have an x squared term anymore. I have this x, which is linear, and the 5x minus 2, which is also linear. From here, I can apply the zero product property, and I'll set each factor equal to 0. Our first factor isn't very exciting. It's actually just x. So I'm going to set x equal to 0. And then our second factor here is 5x minus 2, and we'll set that equal to 0 as well. Now for this first factor, we actually solved it. X equals 0 is already solved for, so there's nothing to solve in the first one. But in the second factor, we're going to add 2 and then divide by 5. So we'll get x equals 0, so I'll just kind of carry down the answer here. X equals 0 and x equals 2/5 as our two answers here. So sometimes we don't go straight to an x games because we might have a greatest common factor that we first want to factor out of the equation before trying an x games. Hey, we have 3 examples left. Let's look at example 8. So example 8 says 2x squared minus 15x equals -18. Well, this is definitely not set equal to 0, so we're going to go ahead and add that 18 to both sides to get 2x squared minus 15x plus 18 equals 0. So now we're set equal to 0. The next step I would need is to know if this is in factored form. What do you guys think? Is example 8 in factored form? So example 8 is not in factored form. I can tell that because I have this x squared term still. So I need to go ahead and factor this. Notice though, I do have a leading coefficient that's now not a 1 in front of the x squared. So when you go to do your x games or your work to factor it, that is going to make a difference, and don't forget to take that into account. Why don't you guys pause the video and factor 2x squared minus 15x plus 18 on your own first. Okay, let's check this together. So to factor this guy, I'm going to still do an x games. Because I have a leading coefficient, I am looking for two numbers that multiply to be 2 times 18. So I have to make sure I multiply my a term and my c term. So I'm looking for two numbers that multiply to be 36 and add to be negative 15. The two numbers that will work for this is negative 3 and negative 12. The other thing I need to keep in mind is since I have a leading coefficient here that is not equal to 1, I can't go straight to writing x minus 3 times x minus 12. This will not work because there's no way to get the 2x squared back. I can always check my factoring by foiling, and when I distribute this, I get x times x, which will not give me the 2x squared. So that is not how we factor these. Instead, we have to split the middle term. So I'm going to rewrite the negative 15x as negative 3x minus 12x. So let's write this out. I still have the 2x squared. Negative 15x is now being rewritten as negative 3x minus 12x. That's still equivalent because negative 3 minus 12 will give us negative 15. And then I still get my plus 18 equals 0. To factor from here, remember we group them. I group the first two together, and I group the last two together. So the first two, what do they have in common? So 2x squared and negative 3x just have an x in common. So I factor out an x, and I'm left with 2x minus 3. What do negative 12x and 18x have in, or negative 12x and 18 have in common? Negative 12x and 18 are both divisible by negative 6, so I can factor out a negative 6, and we're left with a 2x minus 3 then is equal to 0 still. I'm not quite done factoring yet. My last step, now that I have a 2x minus 3 in both of these terms, is to factor out that 2x minus 3. So I get 2x minus 3 times the x minus 6, since that was our leftover stuff here. And that is going to be equal to 0. Now I am finally in factored form. So these quadratic equations, when we have a leading coefficient that's not a 1, they're going to take a little bit more work to factor them, and that's okay. Some of them are still being able to factor, so we can factor them. Now from here we can use the zero product property. So to use the zero product property from here, I'm going to set each of these factors equal to 0. I'm going to drag some space here, so I'll get 2x minus 3 equals 0, and x minus 6 equals 0. To solve each one of these, I can do that now individually on their own. For the first equation, I'll add 3, and then divide by 2, so we get x equals 3 over 2. In the second equation, we can add 6, and I get x equals 6. So those will be my two final answers in factored form then. Or my two final answers for my quadratic equation that we put into factored form. All right, we have 2 examples left. Why don't you guys pause the video and try example 9 on your own first, making sure to think about if it's set equal to 0 and if it's in factored form, or if you first have to factor it. Okay, in example 9, we actually do have to factor this first. So it is set equal to 0, but it's not in factored form because of the x squared. In this case, I want to think about what is my greatest common factor, because at least 10 and 5 definitely have a number in common that I can factor out, and x squared and x also have something in common. So our greatest common factor here is actually 5x. So when I rewrite this quadratic equation in factored form, if I factor out a 5x, then we're left with a 2x, since 10 divided by 5 is 2, and I had 2 x's and I took out one of them, so I just get a 2x to the first. And when I factor out the 5x, although I took out the entire thing, I'm still left with my factor of 1. The reason I still have that 1 there is, think about if you were to multiply these back in. If I didn't have the plus 1, there'd be no way to get the 5x back. So if I would have written like a plus 0, well, 5x times 0 was never going to get us the 5x back, so we want to make sure we have that plus 1 there as our placeholder. Now that we are in factored form, I can set each factor equal to 0. So 5x equals 0, 2x plus 1 equals 0, and we can solve each one of these. For the first one, we're going to divide through by 5, and I end up getting x equals 0, since 0 divided by 5 is 0. For the second equation, we can subtract 1, and then our last step would be to divide through by 2. So we end up getting x equals 0 and x equals negative 1/2. Okay, whoops. There we go. Now into our last example. So on our last example here, it says 6x squared minus 5x minus 4 equals 0. Why don't you guys pause the video and solve example 10 on your own first. Okay, let's check example 10. We are set equal to 0, so that's taken care of, but we are not in factored form yet. So we have to go ahead and factor this first. The other thing I have to worry about is I have a leading coefficient. Now, if I could factor a 6 out, I would, but 6, 5, and 4 do not have any factors in common other than 1. So I'm stuck with the leading coefficient, which means I am looking for two numbers, and I'm going to draw my scratch work on the side instead this time. So I'm looking for two numbers that multiply to be 6 times negative 4. So multiply to be negative 24 and add up to be negative 5. The two numbers that will work for us is going to be negative 8 and positive 3. Again, because we have that leading coefficient, I cannot go straight to writing x minus 8, x plus 3, because there's no way we'll get the 6x squared back. Instead, we have to split the middle term. So 6x squared will stay the same. Negative 5x is going to get rewritten as negative 8x plus 3x. Then I still have minus 4 equals 0. So we've just rewritten that middle term using the two numbers that we got from our x games. From here, I can factor them by grouping. So I'll group the first two terms together. So 6x squared and negative 8x have a 2x in common, and we're left with 3x minus 4, plus 3x and negative 4 don't really have anything exciting in common, but they do have a 1 in common. So we're going to factor out that 1, and we're left with 1 times 3x minus 4. Now from here, my goal was to get the same thing left over inside, and I do. They're both a 3x minus 4, so I can go ahead and factor out 3x minus 4, and then we're left over with the 2x plus 1 in our second factor. And this is why it was so important to remember that we're factoring out that plus 1 so that I get that plus 1 down here in the other factor. Now that we're in factored form, we can go ahead and use the zero product property, which tells me that I can set each factor equal to 0. So we get 3x minus 4 equals 0, and 2x plus 1 equals 0. Solving this guy then, if I solve the first equation, we can add 4, then divide through by 3. So we get x equals 4/3 as one of our answers. And in the second equation, we can subtract 1, divide by 2, and we get x equals negative 1/2 as our second answer. And now we have solved our last example. So solving using the zero product property is what we learned about and talked about in this video. A couple things to keep in mind with that is we always want to make sure our quadratic equation equals 0 first. The second step is we want to make sure that we're in factored form. And we saw a couple different scenarios. We saw examples like 4, 5, and 6, which had a leading coefficient of a 1, so we could kind of do the quicker type of factoring. We saw examples like 7 and 9, where there was that greatest common factor to factor out instead. And then we saw examples like 8 and 10, where there's a leading coefficient in front, which just makes our factoring step take a little bit longer. We talked about all these different types of factoring in our last unit, so if you need a refresher course on any of them, I suggest we go back and rewatch some of those videos just to refresh our minds about what we learned about in that last unit. Once we have our equation in factored form, what the zero product property tells us is that I get to set each factor equal to 0. Then I can solve each one of those linear equations to get my final answer.